Hey everyone, and welcome back to the channel. If you're just starting your journey with Python, you've come to the right place. So far, our code has been a straight line. It runs from top to bottom, one line at a time, and then it stops. It's predictable, a bit boring even. In our last video, we learned about operators, especially those comparison, equals, greater than, and logical, and, or operators that gave us true or false answers. Today, we're going to use those true-false answers to make our code smart. We're going to teach it how to make decisions. This is called branching. And then we're going to teach it how to be efficient. Instead of writing print hello 1,000 times, we'll learn how to tell Python, do this task 10 or 100 or 1,000,000 times. This is called looping. These two concepts, branching and looping, are called control flow. They are the brain of your program. This is the moment we go from writing simple scripts to building real dynamic applications. This is where the magic happens. Let's get started. Branching lets our code choose a path. The main tool for this is the if statement. It's just like how we talk in real life. If it's raining, I'll take an umbrella. The if statement needs one thing, a condition that evaluates to either true or false. This is where our operator lesson comes in. Let's make an age checker for a movie. Now let's use an if statement. Watch the syntax very closely. Okay, two critical things just happened. First, the if statement ends with a colon. This colon tells Python what comes next is the code block to run if this is true. Second, the line under the if is indented with a tab or 4 spaces. This indentation is not optional in Python. It's how Python knows what code belongs to that if statement. The indented block only runs if the condition is true. If we run this, age is 20. 20 greater than or equal to 18 is true, so it prints the adult message, and then it prints the welcome message. But what if the age is 15? Now, 15 greater than or equal to 18 is false. Python skips the indented block. It jumps right past it. See? It skipped the first print. But what if we want a specific message for people who are too young? We can use the else statement. Else is the otherwise. It's the fallback, and it doesn't need a condition. It just catches everything the if missed. This is great, but what if we have more than two options, like a child ticket, a teen ticket, and an adult ticket? For this, we use elif, which is short for else if. You can have as many elifs as you want. Python checks these in order. First, it asks, is 14 less than 13? False. It moves on. Okay, else if is 14 less than 18? True. It runs that block, prints the teen ticket price, and then it skips the rest of the chain. The else block is not run. And that's it. If starts the check, elif gives you more checks, and else is the final catch-all at the end. Remember that colon, and most importantly, respect the indentation. Okay, our code can make decisions. Now let's make it efficient. Loops are for repeating actions. This follows the DRY principle. Don't repeat yourself. The first type is the for loop. This is a definite loop. You use it when you have a sequence, like a string or a list, and you want to do something for each item in that sequence. In our strings video, we learned that a string is just a sequence of characters. A for loop is the perfect way to go through it. Look at that syntax. For some new variable name we just made up, letter, in our sequence, my name, and a colon. And of course, the block is indented. When this runs, Python does the work for us. First, it sets letter equals to p and runs the block. Then, it sets letter equals to y and runs the block. And so on, until it's done. But what if you don't have a sequence? What if you just want to do something 5 times? For this, we have a magical built-in function called range function. This is super important. Range 5 gives you 5 numbers, but programmers start counting at 0. So it gives you 0, 1, 2, 3, and 4. That's still 5 numbers. It just stops before it gets to 5. You can even combine this with an if statement. This is called nesting. For loops are your workhorse. You'll use them all the time. For each item in a sequence, do the indented thing. Simple. Our second type of loop is the while loop. This is an indefinite loop. While a for loop runs for a known number of items, a while loop just keeps going and going and going while, or as long as, its condition is true. This is like telling a robot, keep cleaning while the floor is dirty. It doesn't know how many times it will clean, it just knows the condition for stopping. Floor is clean. Let's make a simple countdown. We'll start a number at 5 and count down to 1. Let's trace this. Python checks, is count 5 greater than 0? True. It enters the loop. It prints countdown 5. It runs count minus equals 1. Count is now 4. Loop finishes. It goes back to the top. Checks, is count 4 greater than 0? True. It prints countdown 4. Count becomes 3. It keeps going. It prints countdown 1. Count becomes 0. Back to the top. Checks, is count 0 greater than 0? False. The loop stops and Python jumps to the code after the loop. The while loop has a dark side, the infinite loop. Look at this code. Do not run this. See what I did? I forgot to subtract from count. The value of count is always 5. The condition count greater than 0 is always true. This loop will never end. It will print that message forever, and you'll have to crash your program to stop it, usually by pressing Ctrl-C in your terminal. When you write a while loop, you must make sure that something inside the loop eventually makes the condition false.
One last thing. What if you're in a loop and you need to get out early? Or what if you just want to skip the current iteration? We have two keywords for that: break and continue. Break is the emergency exit. It kicks you out of the entire loop immediately. Let's search a string for the letter H and stop as soon as we find it. See? As soon as it hit H, it ran the break and the loop was terminated. It never even got to O or N. Continue is different. It doesn't stop the whole loop. It just stops the current iteration and tells Python to continue to the next one. Let's print all the letters but skip the vowels.
When letter was O, the if was true, and continue told the loop, this one's done, move along to N. The print statement for O was skipped. And that's it. Your programs are no longer simple straight lines. They can now think, choose, and repeat. You can combine these in incredible ways. You can have if statements inside for loops. You can have for loops inside while loops. This is the moment you truly start programming. If this video helped you, please hit that like button, subscribe for more, and leave a comment with any questions. Keep practicing, and I'll see you in the next one. Happy coding!